Hey there, welcome back to Research Breakdown, where we take cutting-edge research and break it down so everyone can understand it. Today, we're diving into something super interesting: how scientists are using machine learning and data to predict how much food we can grow. Specifically, we're going to look at soybeans and how a team from Iowa State University combined data from soil and hyperspectral imaging. Don't worry, I'll explain. To predict yields before the crops are even harvested. Sounds like the future, right? Let's get into it. All right, let's set the stage. Normally, predicting how much crop a farm will produce is kind of a guessing game until the very end. Farmers wait until the harvest, run their machines, and then find out how much they got. But what if you could know earlier? Not just by looking at the plants, but by using data from the soil and plants themselves. That's exactly what these researchers are doing. They used something called hyperspectral imaging. Basically, it's a camera that can see things our eyes can't, like how healthy a plant is based on the light it reflects. Combine that with good old soil data, things like nutrients and pH levels, and you've got a ton of information about how well crops are going to grow. But all that data is too complex for a human to just look at and understand. So they used machine learning to analyze it. Now, what's machine learning? It's a type of AI that can find patterns in data. Basically, it teaches computers to make predictions based on what's happened before. In this case, it's predicting how much crop you'll get from the field. Think of it like giving a farm a crystal ball, but powered by data. So what did they actually do? The researchers collected data over 2 years from different soybean fields in Iowa. They measured soil data, things like calcium, potassium, organic matter, and pH. Hyperspectral reflectance data, using special cameras to measure the light bouncing off the plants at different wavelengths, from 200 nanometers to 1,000 nanometers. Yield data, the amount of soybeans produced in each plot, which they use to train their models. Now, let's get to the fun part: machine learning models. They used a method called random forest regression. Think of it like a bunch of decision trees. Each tree looks at part of the data and makes a prediction. Then the results are averaged out. This helps make the predictions more accurate because it reduces the chance of one model making a wrong guess. To make things even better, they used ensemble learning, which is like having a team of models working together. The researchers tried 2 ways to combine models. 1, the field-weighted ensemble, where they divided the data based on where it came from, different fields. 2, the cluster-based ensemble, where the data was grouped automatically by patterns using a method called k-means clustering. Each group got its own model. Let's break this down a bit more technically, but still easy to follow. The researchers' goal was to find the most effective way to predict yield. They tested different models using all this data, but the key was figuring out which data really mattered. First, they looked at hyperspectral data, which is a fancy term for data collected across different light wavelengths. Plants reflect different amounts of light depending on their health. And these researchers used 52 different vegetation indices. Basically, measurements that capture things like how green or healthy a plant is. But collecting 52 pieces of data every time can be overwhelming and expensive. That's where feature selection comes in. They used a method called backward feature selection, where you start with all 52 indices and remove the least important ones one by one until you're left with the few that still give good predictions. Turns out, they only needed 10 of those 52 indices to make accurate predictions. This means they can reduce costs and time without losing accuracy. Big win. They also found that soil data, things like potassium and pH, were super important. In fact, the models using just soil data were often more accurate than the models using only hyperspectral data. But when they combined both soil and hyperspectral data, they got the best results. Now let's talk results. The random forest model they used on soil data alone got an R-squared value, a measure of accuracy, of 0.73. That's pretty good, meaning the model was able to explain 73% of the variation in soybean yield based on the soil data. For the hyperspectral data alone, they got 0.55. Not as good, but still useful. When they combined the data, both soil and hyperspectral, they got even better results. The cluster-based ensemble model, which grouped the data automatically, ended up with an R-squared value of 0.76. This means it was able to make predictions that were 76% accurate. Not perfect, but definitely a big step forward. So what does this mean for farming? Well, if farmers can predict yields during the growing season using data, they can make better decisions about when to water, how much fertilizer to use, and even which crops to plant next season. It saves money, time, and resources. Plus, breeders can use this data to select the best performing crops early in the season, speeding up the development of new, high-yielding varieties. In summary, this study shows that combining soil data and hyperspectral imaging with machine learning can seriously improve how we predict crop yields. The use of random forests and ensemble models lets us get more accurate results with less data, and the possibilities for improving precision agriculture are huge. Imagine a future where farmers have this kind of data at their fingertips. Big shout out to the research team from Iowa State University: Suradeep Chattopadhyay, Aditya Gupta, Matthew Carroll, Joseph Regne, Bhaskar Ganapathy Subramanian, Ashish K. Singh, and Sumik Sarkar. If you want to read the full research paper, I've linked it in the description below. If you found this explanation helpful, make sure to hit the subscribe button for more deep dives into the science that's shaping our world. Also, I want to know, what other ways do you think AI and machine learning can transform agriculture? Drop your ideas in the comments below. Thanks for watching. If you're interested in more tech and science breakdowns, check out my next video on related topic. Stay tuned for more awesome insights into how research and innovation are changing the future.